Hello everyone, this is a video lecture for pre-calculus. We're doing 5.6, graphing part 2. Um, now again, I had the GeoGebra questions first when I first actually prepped this. But I believe things have been shifted around a little bit. There's only the one GeoGebra question I can see right here. The others are all my math lab. Nope. I guess it kind of jumps around. I'm going to follow my notes, okay? So if the question order is all weird, then, well, that's what it is, I guess. I don't know. So this is question 1 from GeoGebra, okay? But I think we need to know a little bit before we even do it. I'm going to show you right quick. We got cotangent of 3x plus pi over 2. Awesome. They say graph it. What? What's cotangent supposed to look like? And that's why I said we need to learn a little bit more. So here we go. These are all the weird graphs. This is why it's part 2. We got cosecant. Let's graph that one first. Cosecant, I actually am graphing a sine, but then cosecant has the U-shapes on the hills and the valleys. Okay, they're not parabolas. There's actually a vertical asymptote in there and all that stuff, but this is good enough for what we're doing. We have secant. What's the opposite of, I'm not saying opposite. What's the No. What's the inverse of secant is cosine. So I'm going to graph a cosine. I don't think inverse is even the right word. What's the thing that we do to make it close? Anyways, same thing. If I draw a cosine and then I do hills and valleys, little U shapes and stuff, that's what a secant looks like. Again, this keeps going forever and ever. Whoa, and forever. On all sides. But that's the first period right there. Okay, let's do some more. I have tangent. So this is a little different now. Tangent looks like this. It looks kind of like a cubic, but there are vertical asymptotes going on right here. And then there's another one here, and then there's another one here, and yada, yada, yada. But we're only focused on this little part here. So because these were pi's, because these were sines and cosines, here we're going out to 2 pi, like usual. But here, this is negative pi over 2. That's positive. Sorry. Well, I could have just kept all that stuff. It's positive pi over 2 and negative pi over 2. And so what we have here is a distance, a period, that's equal to pi. And that is different. That's different. We're not used to that, and we're used to 2 pi normally. So cotangent, the one we actually need for this problem, is the hardest for me to draw, but I'm going to try here. I always goof this one up. Ugh, man, I never like my cotangents. I have got to figure out a way to do that one day. Anyways, it's kind of like a tangent, but it's flipped. 0 is a vertical asymptote, and then over here at pi. So yet again, I have a period of pi. And so whenever I'm doing like my formulas and stuff, it's pi over b. Just like over here, my period is 2 pi over b. So when it comes to tangent and cotangent, our new formula is that we have pi over b. Okay, so that's a little different. Now, back to what we're going to do. What I need to do to be able to do this one is I'm going to factor out the 3 to the front of the cotangent inside, I guess. And I want to have a minus, so I'm going to have a negative. 2 negatives make a positive. I don't know. Whatever you want to do there. Whenever I pull out a 3, I'm actually going to get a pi over 6. Because, again, that 3 is actually in the denominator. Blah, blah, blah. That kind of thing, okay? All right. Sorry, I'm just turning the page here. Okay, that's cool. Okay, so we got that. Let's find my period. And so my period is, again, if you remember, it's pi over b. And this is my b. So I got pi over 3. That's my period. What I'm getting at is that I need to shift this to the left, I also have this new period, and let's go. So I'm going to try my hardest here to make this thing work. Cotangent normally is, again, right here, and then at pi, okay? And then at pi over 2 is in the middle, and it goes up, and it goes down, and all around. So now what I want to do is I'm going to, I guess I'm going to shift it. I'm going to shift it over, oh golly, hold on. Yes. I'm going to shift it over pi over 6. Okay, that's fine. That's fine. We got this. Whew. You're not going to like this at all. I didn't either. I just don't know if I should actually do it this way or not. I don't know. There's not a really good way to do this. There's not a good way. I'm going to shift this thing to the left by pi over 6. So that's like right here, that amount, very tiny amount. So instead of at 0, I now have a negative pi over 6. Instead of pi, again, everything gets shifted over a little bit here, okay? Instead of pi, I have 5 pi over 6. And then instead of pi over 2, you actually end up at pi over 3. I know that's kind of weird. So pi over 2 minus pi over 6 is pi over 3. And then you draw it again. Yay! And we're not done. Because my period is equal to pi over 3. Not pi. So this is also wrong. Let me start over and show you why, like what I'm actually working with now. So what I should do now is, like back at the original, I needed to end at pi over 3 and then do this stuff, right? Okay, fine. So now I'm taking this guy and I'm going to shift it over by pi over 6. But what happens is that this is at pi over 6 and I'm going to shift it over here to 0. So this is actually totally wrong. Ooh, Chad, I don't like you anymore. Well, did you know how to draft this thing? Because I don't. So we're just doing the best we can together. So here we go. 0, I'm shifting over pi over 6. This, I'm shifting over pi over 6. This guy, I'm shifting over pi over 6. So negative pi over 6, 0, and it actually ends up right here at pi over 6. Pi over 3 minus pi over 6 is pi over 6. And then I draw my cotangent. There you go. So that's a shifted and the new period. If someone's asking, it actually is right here at 1 and negative 1 in the middle of this. So this is now going to be pi over 12. So negative pi over 12. And right here, pi over 12. If someone asks. There's your final answer. Now, I have a note in my notes. Are you ready? It says, ooh, that was annoying for question 1. So it might not be your question 1 anymore, but it was annoying. And I put it in all caps just so that you can know that I really didn't like it either. Okay, that's fine. It was a fun little problem. We're learning. So the next one is actually like a matching. So I got 1 through 4. Actually, no. You know what? I don't know if it's matching. I might have just done it 4 times. I can't remember. No, it says matching. Okay, it says matching. It's fine. Okay, yeah. So let's do this thing. Now, I'm just gonna make a little point here. If you ever get confused and you don't know what to do and you need to graph this thing a little bit, guess what? Desmos graphing. I know that you can't use it on the exam, but we're not doing the exam right now, are we? We're doing the homework. And so if you need to do a little bit of help once in a while, that is okay. All right, so this is actually going to be shifted to the left by pi. And so my original, which was here at negative pi over 2 and pi over 2, and this is my normal tangent, I'm actually shifting this over. This is pi over 2. This over here is pi. I'm shifting my 0 all the way over here. You know what's funny, though? Let me do that, actually. Yeah, let me do that. yeah, guess what? It looks the same. So it got shifted over, but the next one will overlap the original, and the next one is right here. Blah blah blah. What actually happens is that it looks. I'm gonna say tilde just in case I'm not exactly sure, but it sure looks like the original. Just saying. Next one, I got negative tangent of x. The negative in the front is flipping it upside down. So it was like this. Now it's like this. And of course, there's like a lot more other ones with it too. Okay. Let me get out of red. I don't want red anymore. We got y is equal to negative tangent of x minus pi over 2. So I'm flipping upside down, and I'm shifting it to the right by that pi over 2. So it actually is going to end up here at 0 and at pi. But instead of doing my normal tangent, it's flipped upside down. And so what happens is that it does this, which is oddly similar. I'm going to put tildes just in case. Oddly similar to the cotangent. And then finally, we've got tangent of x plus pi over 2. So I'm shifting it over by pi over 2. It was at negative pi over 2 and pi over 2, 0. So I'm shifting it over, shifting my 0 over, shifting this over. And so it actually is going to end up looking like this here. And this is now at negative pi. Okay. Whew. Keep cruising. 5, 6, 25. So we got y is equal to negative 1/6 sine of x over 4. I'm used to pi's, but there's no pi right there. It says rewrite with reciprocal function. Huh? Oh my gosh, this is so funny. It's hilarious. Okay, well, we figured out the name, though. It's the reciprocal function that I was talking about earlier, that I didn't know the name for it. Reciprocal function. Let me tell you why. So I went and got this one wrong so that you didn't have to. And it says my answer is, you ready for this? Negative 1/6 cosecant of x over 4. Yeah, that's it. That's your reciprocal function, right? There you go. Now we got a name for it. And that's it. Yay! And I even put on my notes, too easy? I'll take it. Okay, that's great. I love that. Part A. So part B says find the graph of this thing. And I'm just going to do a rough graph here. What's going on is that it actually starts down here and it comes up. This is my sine. That's this thing. But then my cosecant again has the U shapes on my hills and valleys. Okay, so that it kind of ends up looking kind of like this here in the end. A, B, C, or D, pick that one, moving on. Okay. I actually only have 2 problems left, so we're almost there, guys. 5, 6, 39. I've got y is equal to negative 1/4 secant of 2 pi x. They say graph this thing. So you go to Desmos graphing. Kinda. So it's 1 over cosine. And so I'm going to definitely graph a cosine. Notice that this is my b. So I'm saying that b is equal to 2 pi. No, my period. Hold up. See, I always get these mixed up. My period is equal to 2 pi over b, but my b is 2 pi. 2 pi over 2 pi is a 1. My period is 1. So when I'm graphing this cosine, I know that it's negative and all that stuff. So it's going to be negative down here, and it goes up, and da-da-da-da. In the end, I'm going to stop at 1. So that's kind of different. Okay, cool. So I flipped it upside down. This is supposed to be at 1/4. This is supposed to be at negative 1/4. And so then hilltops, valleys, U-shapes, all that kind of stuff. There you go. Okay, last one, which apparently I got wrong because I have a huge, like, X through this thing. Y is equal to 3 tangent of x plus pi over 4 and then minus 1. I don't know what I did wrong. Oh, I shifted it to the right. This is a shift to the left. Now I see what I did wrong. That's a common mistake, actually. So what I had done is I shifted it to the right. Totally not that. It's to the left. This is going down. This stretches it a little bit, but it's very hard to tell the stretch stuff, especially when it's multiple choice. And so I'm just going to draw the best I can. Instead of starting at 0, I'm going to start right here at negative pi over 4, and then down here at 1. That's my new center. My pi's and stuff, this is now at pi over 4 for my vertical asymptote, and this over here would be at negative 3 pi over 4. Okay, and then I'm just going to graph it. Okay, so here's my cosine, or tangent. Sorry, just my tangent. My tangent. Boom, there it is. Done. Awesome. I even have a note here. It says very hard to see the differences in the multiple choices. So again, look for what you can. Try multiple choice. Eventually, you'll get it. That's all I got. Thank you very much, and have a great day.